Welcome to this video. Thank you so much for joining me. Thank you so much for coming to my YouTube channel, for taking time to watch this video. In this video, I'm going to go through science paper 1, that is physics paper. I'm going to answer all the questions that came in this paper. So all I want you to do is watch this video up to the end. And if you haven't subscribed to my YouTube channel, I encourage you to subscribe to my YouTube channel. And if at all you find this video helpful, remember to like and share with your friends, so that they can also learn with us and prepare for the exams. With that being said, let's get started. As follows: a learner measured the diameter of a test tube and obtained 1.5 by 10 raised to the power of -3 millimeters. What is the value obtained in decimal form? Okay, so A, we have got 0.15 millimeters, B, 0.015 millimeters, C, 0.0015 millimeters, D, 0.00015 millimeters. So how do we get the correct answer here? What we need to do is we're going to write the number that is we have found that the learner found 1.5. okay, 1.5 okay times 10 raised to the power of -3. Okay, so what we need to understand there is when we write 1.5, okay, so this is 1.5 and then the point is here. -3 is telling us that the point should move 3 places on going to the left side. So it's more or less like 1, 2, 3, okay, like that. So that means here we're going to put a 0 and here we put a 0. That means the point is there. That means we put a 0 here, which will be 0.0015. okay, so the correct answer is C. Okay, we come to question 2, which is a car traveling at 10 meters increases velocity to 30 meters per second in 5 seconds. What is acceleration? So we can understand that this is initial velocity and this is final velocity, okay, and this is the time taken. Okay, so what we can do is to find acceleration. We use the formula, which is acceleration is equal to final velocity minus initial velocity over time. Okay, so what is the time, or what is the acceleration? So not time. So where there is final velocity, we're going to put 30 meters per second, and where there is initial velocity, we're going to put minus 10 meters per second over time. What is the time? 5 seconds. Okay, so what we can do now here is we find the difference of 30 and 10, which will give us 20. So we are going to get something like 20 meters per second. Okay, 20 meters per second. Then we say, now what is time? Time, we know that is 5 seconds. So we say divide by 5 seconds. So 5 seconds, then 5 into 20 will give us 4. So that is 4 meters per second squared. So the correct answer is A. Okay, the correct answer is A. Okay, we come to question 3, which is as follows: the displacement time graph shows the motion of a cyclist. Okay, so we can look at the time graph, displacement time graph there. Then what we can do now, we can go to the actual question, which is what was the speed of the cyclist at time 4 seconds. At time 4 seconds. So the speed we want to calculate is between here, this point, okay, up to here. Okay, so now what we can see is, you can see that in 5 seconds it covered 5 meters. Okay, and we know that the speed here, the increase of speed here was constant. Okay, okay, the increase of was constant. So meaning the speed here was constant. When we look at not the increase of speed, we are saying the speed here was constant. When you look at it, it took 5 seconds to cover 5 meters. So that means the speed was constant. So what we can do is to find the speed, we can use the formula, which is now, since we are not given 4 meter, the reading on 4 meters, and we can't identify where 4 meters is. So whatever point we're going to use to find the speed is applicable even at 4 seconds. So the interval we're given is 5 seconds and 5 meters. So we can say speed is equal to distance over time. So what is the distance? We are told that was 5 meters and the time was 5 seconds. So when we divide this 5 into 5, it will give us 1. So that is 1 meter per second. That was the speed. So the correct answer is A. Now, you may be wondering that I've used the 5. Like I said earlier on, since this was constant speed, so whatever interval we use implies to even other intervals, since it is the speed was constant. Okay. Okay, we come to question 4, which is the energy output of a generator depends on its efficiency and the energy input, which set of value is correct. Let me read the question properly. The energy output of a generator depends on its efficiency and the energy input, which set of values is correct. Okay, so for us to get this answer, for us to get this question correct, what we need to do is we need to know the formula for efficiency. Now, the formula for efficiency is efficiency. Okay, efficiency is equal to energy output. Okay, energy output over input. Okay, times 100. Sorry for the space there. 100%. Okay, now when you look at this, whatever we are given here, it's more or less like they didn't multiply by 100%. Okay, so now what we need to do is, what you can do, if you have time, you can try all the numbers, or what you can do is you can just check if you divide if you divide the energy output by the energy input, are you going to get the efficiency that is given here? Right? You try the numbers if you can. Okay, so what we can do is we can say if we have 25 on top and 50 down, never mind about the decimal point, what answer can we get? Okay, so when we say 5 into 50, 5 into 50 into 25, it can't. So 50 into 25, it can't. So until we put 0 here, and here will be 0 point, then we say 50 into 250 to go 5 times. So we can see that the efficiency is 1. So it's not 0.5. That one is 0.1. That means the answer is not correct. Okay. Now, once you have done that, you can also try the other numbers as well. Okay. There you can also try other numbers until you see which one will give you. So if we try the output here, we have is 6. And down we have 30. Okay. Then we say equal to, so we say into 30 it can't, so we put 0. Then we put a point, and then we put a 0 here. 30 into 6 will give us 2. So I've got 0.2. So you can see that there I've got 0.2. Definitely B is correct. Okay. And you don't have to go even any further. Just like that, you have found the answer. But you can even try other numbers. You find that the answer will give you, they will be wrong. If there will be any answer that will resonate with that, then that means there is an issue with the way the question was prepared. So the correct answer there is B. Okay. Okay, we come to question 5, which is as follows. A crane lifts a 600 kg mass through a height of 12 meters in 18 seconds. What is the useful power output of the crane? Okay, so to find the power of the crane, we're going to use this formula, which is power is equal to energy. Okay, that is energy over time. So in this case, we are talking about potential energy. So how do we find potential energy? To find potential energy, we multiply the mass times height times gravitational force or gravitational acceleration, which is we are going to say 600 kg times 600 kg times 12 meters times gravitational force, which is 10 meters per second squared, over time, that is 18 seconds. Okay, now 18 seconds, what we can do now here is, first we need to simplify the numbers. That's a key thing to get the correct answer. We don't have to have a lot of bigger numbers. So that means we have 18. Okay, so we look for a number that can go into 18 and 12, that is 6. So 6 into 18, it will go 3 times. 6 into 12, it will go 2 times. Okay, then we come to, is there any other number that we can use? So we have 600 here. So here we can use 3 into 6, it will go 3 into 3, 1, 3 into 6, it will go 2 times. So now we are remaining with, we write what we are remaining with. There we are remaining with 200 kg. Sorry with my writing. 200 kg. So there we have 200 kg times 2 meters times 10 meters. Okay, so you say S down here and 1 S here, so we remain with a single S, that is meters per second. So we have meters per second, not meters per second squared. Okay, then over down here we don't have anything, so we just multiply 200 times 2 will give us 400, 400 times 10, so 200 times 2 will give us 400, 400 times 10 will give us 4,000. So the answer is 4,000 watts, and that is the answer. So the correct answer is B. We come to question 6, which is, by what process or processes is heat energy transferred from the sun to the surface of the moon? Okay, so what form of heat transfer is heat transferred from the sun to the surface of the moon? Okay, so between the sun and the moon, for the heat to travel through that space, there is no need of any medium. Okay, there is no medium where heat passes through to reach the moon. So the answer will be G, which is radiation. So the heat passes through the space to the moon through radiation. So the answer is radiation. Okay, so that is radiation. Okay, so we come to question 7. What happens to the speed, wavelength, and frequency of a water wave when it moves from deeper end to the shallow end? What happens to the speed, wavelength, and frequency of a water wave when it moves from deeper end to the shallow end? Okay, so first of all, let me start with the speed. So when the wave is moving from the deeper end to the shallow end, what happens to the speed is it reduces. The speed reduces. Okay, so now when we look at the answers that we are given, we have got A increases, B increases, D same, C reduce. So here we can even tell that the correct answer is C. Now for revision's sake, let's check this about wavelength. Wavelength. Okay, wavelength, we can say when speed reduces, that means even the wavelength reduces. Okay, so we can confirm that is correct. As you can see, others they don't have reduced. And then frequency. Frequency is not dependent on the depth of the water. Okay, wavelength is dependent on the source where it is coming from. Okay, frequency depends on the source, okay, of the wave. So the correct answer is C. Okay, so if you have got questions, please don't hesitate to ask in the comment section. Okay, we come to question 8. What waves were produced in a... Question 8 is, Water waves were produced in a limpo tank using a vibrator of frequency 6 Hz. Which of the following values of speed and wavelength could the waves have had? Water waves were produced in a limpo tank using a vibrator of frequency 6 Hz. Which of the following values of speed and wavelength could the waves have had? Okay, so for us to find the correct answer for this question, what we need to do is we need to come up with an expression that will help us to find this. And the common expression that we can use is velocity, speed of the wave is equal to frequency times wavelength. Okay, so what we can do is just when you make f the subject of the formula, so frequency, so we're going to say f is equal to velocity over wavelength. Okay, all right, so that is what is there. Okay, so in case you're wondering how you can make frequency the subject of the formula, from this we can say speed is equal to frequency over wavelength. So we have wavelength like that. So what we do, we divide both sides by wavelength. We divide both sides by wavelength and this side by wavelength. That means we're going to have speed is equal to wavelength is equal to, then with this wavelength and this wavelength will cancel each other, leaving us with the frequency. Okay, so now in physics, changing the subject of the formula is one of the skills that you should have so that it can be easier for you to manipulate formulas. Okay, now once I've come up with this, then we can go to the options that given. We know that the frequency we have is 6 Hz. Okay, so for us to get 6 Hz, which numbers can we divide? Okay, so when you look at, we divide, now remember speed is 2 and this is 6 centimeter. So when we divide wavelength, we will divide the speed by the wavelength, which is 6. We are not going to get 6. Okay, we divide 4 by 2, we are going to get 2 as the frequency and not. We divide 30 by 10, we are going to get something like 0.33, okay, as the frequency, which is not correct. But when we use 12, if we have got 12 as the speed, so centimeter per second over 2 centimeters, so 2 divided by 12 divided by 2 will give us 6 Hz. So the correct answer is G. Okay, unless if you have got questions. If there are no questions, basically that's how we go about it. Question 9. Sound waves are being produced by radio, loudspeakers, industrial machinery, and children in a playground. These sound waves have the same. Okay, so there are 3 types of sound that are being produced. One from the radio, loudspeakers, industrial machines, and children in a playground. What do these sounds have in common? Okay, let's look at A, which is amplitude. Amplitude determines the loudness of sound. So that means these 3 sounds, they do not have the same amplitude. Okay, so the amplitude is different. So the A is not correct. B, frequency. Frequency determines the pitch. So the pitch is different. The pitch is different of these 3 sounds. Okay, so which means the frequency is also different. C, speed. Okay, we know that the sound of speed is just the same. Okay, so let's not first put C as the correct answer. Let's look at D, wavelength. Wavelength determines how or low the pitch is. So that means also wavelength may not be the same in these 3 sounds. So the correct answer is B, which is same speed. So the answer is C. Okay, the answer is C. Okay, we come to question 10. The diagram shows refraction when light rays strike a rough surface. So I've got incident ray, reflected ray, okay, and we have got the rough reflecting surface there. Okay, so the actual question is, what kind of refraction is represented in the diagram? Okay, so what I can tell you is this. I would have gone through the definitions of what the angular refraction is, diffusion refraction is, as well as the parallel refraction, transparent refraction. What I'm going to promise you is that I'm going to make a video on this one so that I give you the detailed explanation on this. Because if I just give you a rough ones, you may be confused because somehow they feel like they are difference. They have got a thin line in between. Okay, they're just thin line in between these kind of refraction. So which one is the refraction? That is, what kind of refraction is represented in the diagram? So the refraction that is from the rough reflecting surface is C, which is diffusion. Okay, which is diffusion. So let me talk about diffusion. That's the only type of refraction I'll talk about in this question. Diffusion refraction is the scattering of light rays from a surface that is not perfectly smooth. That is diffuse refraction. So that is the correct answer there. We come to question 11, which is as follows. The diagram shows a boy standing 3 meters away from a plane mirror. He then moves 1 meter closer to the mirror. Okay, so when look at this diagram, that means the boy is standing at 3 meters, then he comes closer and he comes to 2 meters. So the question is, how far is he from the image? How far is he from the image? Okay, so meaning when the boy is 2 meters away from, let's say this distance now is 2 meters. Okay, that means the image also will be formed, will be 2 meters away from the mirror. Okay, that means now we add 2 meters plus 2 meters will give us 4 meters. So the correct answer is C, because the question is asking us how far is he from the image. So we calculated the distance from the actual image to the actual person where he's standing to his image, which is 2 meters away as well. So that means it will be 4 meters. Okay, we come to question 12, which is as follows. Which of the following is a characteristic of an image formed by a plane mirror? Which of the following is a characteristic of an image formed by a plane mirror? A, diminished. No, they are in the same image. When looking in the mirror, you see the actual image of the actual size of yourself. Magnified, no, it's not bigger, it's just the same size. Real, no, that is virtual. D. So the correct answer is D. Okay, we come to question 13, which is as follows. Which of the following best compares the magnetic properties of iron and steel? Okay, so I can take time and look at the answers. We have A, difficult to magnetize, difficult to magnetize. No. B, difficult to magnetize, easy to magnetize. C, easy to magnetize, make temporal magnet. D, make temporal magnet, difficult to magnetize. Now let me talk about the answers. Difficult to magnetize for iron, that is making the answer A not to be correct. Okay, so it's easier to magnetize using the iron than it is with the steel. Okay, B, difficult to magnetize, like I said earlier on, this is making also B not to be correct. C, easy to magnetize, yes, but steel makes temporal magnet. No, that is not correct. So D, makes temporal magnet, yes. Difficult to magnetize, yes. So the correct answer is D. Okay, the correct answer is G. Okay, question 14. The diagram shows two metal spheres R and S touching each other, placed on insulating stand. A negative charged polythene rod is held near sphere R to separate the metal sphere. Okay, so we can take time and start the diagram. We have the negative charged rod here and insulating stands there. So the actual question is, what charge will be on sphere R and S respectively? Okay, so the charge that will be on S will be positive and on R will be a negative. So the correct answer is C. The correct answer is C. Okay, the correct answer is C. Okay, we come to question 15. A battery moves a charge of 70 coulomb around a circuit at a constant rate in 1 minute. What is the current flowing in the circuit? Okay, so we need to find the current. So we are told the charge is 70. So what we can do is we can just say the charge is 70. So the charge is 70 coulomb, which is equal to, so we want to find the current, so we are also given time. Okay, we are also given time, and then what we want to find is time, which is 1 minute. So we change 1 minute into 60 seconds, so which is going to be under time, we're going to have 60 seconds. Then over there we can say current. We need to find current. Okay, so what we can do is now what we can do now is we need to find current. So to find current, we're going to say current is equal to the charge, okay, which is 70 coulomb over 60 seconds. So when we divide that to find current, we're going to say 6 into 60 into 70. We can even cancel the zeros. Then we say 6 into 7 to go one time, remainder 1. So 6 into 1 it can't, so we make it 10. So we say we even put a decimal point here. Then we say 6 into that, which will go one time again, to go one time here. Then we have remainder 4. So into 40, 6 into 40, how many times will 6 go into 40? So it should be somewhere, so it should be 6 times. Okay, now 6 times again remain with 40. So when we round off, if we get 40 again, we round off that, because I don't want to have lot, so I'm going to be getting 666 just like that. So we round off to 2 decimal places. That means we're going to have 1.17. So the answer is D. The answer is D. Okay. Okay, we come to question 16, which is two resistance of 12 ohms and 24 ohms are arranged in parallel. A 4 amp current flows through a 12 ohm resistor. Okay, so what we need to bear in mind is that the voltage that is in this circuit is the same at each point, is the same. Okay, regardless of the point, the voltage that is flowing through this circuit is the same. So what we can do for us to find the value of the question, which is what is the reading of the current on the ammeter A. So this is the ammeter A. What is the reading? Okay, so we have the voltage, which is 48. Okay, sorry, which is voltage is equal to, let me find the voltage, which is voltage is equal to current times resistance. Okay, so what we can do is, what is current? We are told here we want to find the voltage that is here. So using that, those quantities were given. So the current is 4 and the voltage is 12. So when we multiply that, is going to give us 48 volts. That is the voltage. So this is the voltage that is passing through the entire circuit. Now, for us, what we need to understand is, we need to understand that for us to find the reading of ammeter, there we have circled the ammeter that is in question, we need also to find the value of the resistant in here. Okay, so for us to find the current that is here, so the current that is passing through the resistant, which has 24 ohms. What we can do is first we find the current. So current is equal to voltage. Current is equal to voltage over resistant. So the resistant that is there is 24, and the voltage we found is 48. So where there is voltage, we're going to put 48 over resistant, which is 24. That means the current we're going to get is equal to 48 divided by 24 will give us 2. So that is 2 amps. Now, how do we find the reading on that ammeter? We are going to add the 2 amps plus the 4 amps. Okay, the 2 amps plus the 4 amps. Okay, so when we add that, we have 4 amps plus 2 amps, which will give us 6 amps. Therefore the correct answer is B. Okay, the correct answer is B. Okay, if you have got questions, please you can ask in the comment section. I'm trying to be very fast and trying to use simple way without explaining a lot, so that I can shorten the time I'll spend on solving this one. We come to question 17, which is as follows. The diagram shows a coil in a magnetic field. So we have got the diagram there. So that is permanent magnet. We have south and north there. Then we have the coil. And then we have got J and K there. So the actual question is, when the coil forms part of a DC motor, what must be connected to J and K? Okay, when the coil forms part of a DC motor, what must be connected to J and K? So the correct answer here is D, split link, which is D, which is split link, which is split link. Okay, that's the correct answer, D, which is split. Okay. Okay, we come to question 18, which is as follows. A transformer is needed to convert a mains 240 volt supply into 6 volt supply. If there are 1000 tanks on the primary core, how many tanks should there be on the secondary core? So how do we go about this one? So what we need to understand is that first of all, we are told that there are 240 volts on the primary supply, and it needs to be converted to 6 volts. Okay, so what we can do is we can first come up with number of volts on the primary divided by number of turns on the primary, which is equal to number of volts on the secondary divided by number of turns in the secondary. Okay, so what we can do is we can replace them with the numbers, which is volts on the primary is 240 volts, okay, over number of turns we are told 1000, so that is 1000 turns, then which is equal to number of volts on the secondary, it's supposed to be 6 volts, sorry, it's supposed to be 6 volts over number of turns, we don't know, so we can denote it by X. Then what we do is, what we can do now is we cross multiply. So when we cross multiply, we're going to come up with 240x, okay, is equal to, then 1000 times 6, so we have got 1000 times 6. Now we need to be very slow in coming up with bigger numbers so that we don't confuse. So what we do is divide by 240 on both sides so that we remain with the value of x, or we remain with x on one side of the equal sign. So what we do is this 240 and this 240 will cancel each other out, leaving us with x, which is equal to, then this 0 and this 0 will be cancelled out, then 6 into 24 it will be 4, 6 into 6 it will be 1. Okay, then we say 4 into 100 will be 25, so 4 into 100 will be 25. So that is the answer. It will be 25. When you simplify that, I'm sure I haven't made any mistakes. So where do we have 25? That is on A. So the correct answer is A. Okay, we come to question 19, which is radon decays to polonium by emission of alpha particles as shown by the following decay equation. So we can take time and study the decaying equation. Okay, now once we have studied, we can come to the actual question, which is what are the values of P and Q? Okay, so what we should understand first is that when decay is taking place, and then we have this, which is the atomic mass number and the atomic number, which will be denoted by Z. When we have these, you should understand that the mass number when decay is taking place reduces by 4, and the atomic number reduces by 2. Okay, so now what we need to do now in this season, we just have to add these numbers we have gotten to these numbers that are given here. Okay, so we have got 218 as the mass number, so we add 218 to that mass number will be 222, and then we add 2 to 84, it will be 86. So which one has got 222? That is D. First of all, for the mass number with the value of P, we have 222 on D. There is no other option which has got 222. So that means we can even determine using the value of P to determine the correct answer. However, when we add 2 to 84, we're going to have the value of Q, which is 86. So the correct answer is D. That is the correct answer, D. Okay, we come to question 20, which is as follows. An industry buys 200 grams of radioactivity sample with a half-life of 5 years. How much of the radioactivity sample will remain after 20 years? Okay, so what we need to understand is we need to understand the formula. So the formula to find the remaining sample is we have sample that remains, which is denoted by N, over initial sample, which is also denoted by N. We can put like that number, like, then which is equal to half-life multiplied by N, okay, which is the quotient of time divided by half-life. Okay, so now what we can do is this. First we need to find first we need to write N, because we are not given the we want to find the sample that will remain, which is denoted by that N, and then initial sample, that is 200 grams. Initial sample is given here, which is 200 grams, and then equals to what is half-life. So what we need to do is we need to write half-life over 2 times not the way I've written, it should be like this. Then what is N? I said N is the quotient of dividing the time taken by half-life, which is 5. So we say 20 divided by, so here let me write here, we have 20 years divided by 5 to give us, so we can say N is equal to 20 divided by 5, which will give us 4. Okay, so that means you are going to put 4 there. Okay, I hope we have understood what I mean there. Then what do we do now? So now once I've done that, the next thing we're going to do is now we're going to evaluate that. So the first thing we're going to do is, before we even go any further and evaluate, what we're going to do is we're going to write N over 200, okay, is equal to, so we distribute that power, okay, laws of indices. That means we are going to have something like this. Okay, let me demonstrate down here. So we're going to have something like 1 raised to the power of 4 and 2 raised to the power of 4. Then we say 1 times 1 times 1 4 times, which will give us 1. Okay, then we say 2 times 2 4 times, so 2 times 2, that is 4, 4 times 2 8, 8 times 2 16. So we have got 1 over 6 in there as the answer. So we say which is equal to 1 over 16. Then what we do is we cross multiply. So what we're going to get, so we're going to have something like there we're going to have 16 N is equal to 200 grams. Remember it's grams here. Then we divide both sides by 16 and this side by 16. Okay, which is going to be like this. So 16 here and here will cancel each other out, leaving us with n, which is equal to so we divide 200 by 16. Okay, so we should have something like 12.5 here as the answer. So 12.5 grams is what you mean. So the correct answer is A. Okay, unless if you have got questions, but have been all over the screen. If you have got questions, you can ask in the comment section. Okay, we have come to the end of section A. Now let's go to section B. We come to section B, which has got 40 marks. Section B is as follows. Answer all the questions in this section. Write your answers in the spaces provided. Those are the instructions for section B. So let's start with the section B, question 1, which is as follows. Figure B1.1 shows the many parts of measuring instrument found in a laboratory, labeled as A and B. Okay, so what we can do is we can take time and study the diagrams. Now, once we have studied the diagrams, we can go to the actual question, which is name the instrument A and B. Name the instrument A and B. So the instrument A is micrometer screw gauge. Okay, that is micrometer screw gauge. Okay, that is micrometer screw gauge. Okay, what is the name of the instrument B? The instrument B is vernier calipers. That is vernier calipers. The instrument B is vernier calipers. Okay, let's go to question B, which is which physical quantity is measured by instrument A and B? Which physical quantity is measured by instruments A and B? The physical quantity is length. So we use vernier caliper to measure length. We use micrometer screw gauge to measure length. Okay, so it's on that we use these instruments to measure length of small objects. Okay, we come to question C. Which instrument is most suitable to measure the thickness of a laser braid? Which instrument is most suitable to measure the thickness of a laser braid? So which one can give us the more accurate measurement? That is micrometer screw gauge. Micrometer screw gauge. Okay, so basically these are the answers for this question 1 of section B. Okay, if you haven't subscribed to my YouTube channel, I encourage you to subscribe to my YouTube channel. And if you find this video helpful, remember to like and share with your friends. With that being said, let's go to the next question. Question 2B, which is as follows. We come to question 2B, which is as follows. Figure B2.1 shows a wooden ladder of length 4 meters inclined at a vertical height of 1.5 meters. A ladder is used to pull a 900 Newton suitcase by applying a force of 450 Newton. Okay, so we can take time and study the diagram. Now, once we have studied the diagram, we can go to the actual questions, which are as follows. So we go to question 1. Question 1 is as follows, which is question 2A, which is as follows. Define a simple machine. What is a simple machine? So we can say a simple machine is a device that makes work easier. It's a device that makes work easier. Okay, that is a simple machine. Okay, we are saying a simple machine is a device that makes the work easier. Okay, so that is a simple machine. Okay, now we come to question 2B, which is calculate the velocity ratio of the ladder. So what is the velocity ratio of a ladder? So to calculate the velocity ratio of a ladder, we use we write velocity. We say velocity ratio is equal to distance moved by effort. So we are saying distance moved by effort. I'll just use a shorthand over distance moved by load. So that is the key thing. So load, okay, which is, now we can say what is the distance moved by effort. Okay, the distance moved by effort, that is the distance moved by effort, sorry, that is 4 meters. Okay, 4 meters. So 4.5 meters, sorry. So I'm going to write 4.5 meters there. Then what is the distance moved by load? So the distance moved by load, that is when you come there, that is the vertical height, which is 1.5. Okay, 1.5 meters. So we say divide by 1.1. We say divide by 1.5. This is not 11, but this is 1. This is 1. Okay, 1.5. So when we divide 4.5 by 1.5, we get 3. So the velocity ratio is 3. Okay, so that is the answer. Velocity ratio is 3. C. Calculate the work done on the parking case against gravity. So the work done. So to find work done, we use the formula, which is work done is equal to, work done is equal to force times distance. That is force times distance, which will be equal to, so what is the force? So when you go on the statement there, you are going to notice that the force we are given is 900 Newton. So we are going to get 900 Newton. Okay, 900 Newton, that is the force of the case. Okay, which is a ladder is used to pull a 900 Newton suitcase. That is the force that we are given there. Then times the distance, so it is going upwards, that is 1.5 meters. So we say times 1.5 meters. Okay, times 1.5 meters. So when we multiply that, we should get something like, we can say is equal to, so we just remove the decimal point, then we multiply 9 times 15. 9 times 15 will give us 135. Okay, so that means if there are 2 zeros here, since we moved the point away and we multiplied by 15, that means we just add 1 0. Okay, well, the other 0 was to convert 15 into a whole number, not a decimal number, into a whole number. That means the remaining 0 is the one that we add to the answer. The other 0 moved the point to this side so that it becomes 15. Then the other 0 add to that one. So that one will be joules. Okay, remember we are looking for work done. That will be 1350 joules. Okay, now we come to the question, which is calculate the efficiency. Okay, so to calculate the efficiency, we are going to use the formula, which is efficiency. Okay, which is efficiency is equal to work output. So we can, I'll just put the word output here. Okay, output over input, or yes, over input, or let me use this one, which is more easier and you can easily use this one. Let me use this one. So I'm going to use the one where you can use mechanical advantage over velocity ratio. Okay, so we already have velocity ratio. So what we need to do is we need to find mechanical advantage. So to find mechanical advantage, what we're going to do is mechanical advantage is equal to mechanical advantage is equal to load over effort. So what is the load? We know that the load is 900. Then when you go on the statement there, it's pulling the suitcase of 900 Newton, and applying the force of 450 Newton. So that means the load is 900 Newton and the effort is 450 Newton. So when we divide that, we are going to get the mechanical advantage, which is 2. Okay, so that means now we can put 2 here as the mechanical advantage. Now before we write 2 there, what I want you to correct here is one thing I didn't include is multiplied by 100%. Sorry, I was too fast. Then what we do is we say mechanical advantage, which is 2 over velocity ratio, which is we got 3. We got 3 there. So we say over 3 times 100. Okay. So when we divide 2 by 3, we are going to get 0.666, and it will continue to be 66 multiplied by 100, which will give us 66.6%. And this is the efficiency of the simple machine. This is the efficiency of the simple machine. So basically that's how you can find this one. Okay, so I used mechanical advantage and velocity ratio. You can also use the output, work output and work input. You are going to get the same percentage. So if you are comfortable using the work done, work output and work input, you can also use that one. You are going to get the 6.6%. Okay, so if I write it to 1 decimal place, if I want to write it to 2 decimal places, let me in fact okay, so when I want to write it, if I want to write it using 1 decimal place, that means it's going to be 66.7, because I'm going to round off, because I will be just getting 666. But if I want to write it into 2 decimal places, that means my answer will be 66.67%, like that. Okay, so that is the answer. If you have got questions, you can ask in the comment section. If there are no questions, basically this is how I'll go about this question. Come to question 3, which is a crane lifts blocks through a vertical height of 24 meters with a force of 5,000 Newton at a constant speed of 6 meters per second. It takes 4 seconds to reach the top of a building. Okay, so that's a statement. Now the actual question is, A, how much work is done in getting the blocks to the top of the building? Okay, so the work that is being done to get the blocks on top of the building. So what we're going to do is we're going to say work done is equal to, so work done, like we did earlier on, is equal to force times distance. Okay, so now what we need to do is we need to go there and check on we need to go to the statement and check on the force. We have discovered that the force is 5,000 Newton. So we say 5,000 Newton times the distance. So the distance we are told is 24 meters. So we say times 24 meters. So what we need to do is just to multiply that one. Okay, so what we need to do is we forget about the zeros that are in 5,000, then we just concentrate on 24 times 5, which will give us 120. Okay, then we forgot about 3 zeros from 5,000, then we add the 3 zeros to the answer. That means it's going to give us 120 joules. So work done is equal to 120 joules. Okay, so don't forget the symbol joules. Okay, now we come to B, 3B, which is what is the potential energy gained by the block? Okay, so the potential energy gained by the block, so what we can also consider is that is work done is the same as the energy that is being attained. Or in other words, we can say potential, if we want to calculate, we can go like this. Potential energy, let me abbreviate it, the word energy, is equal to M times gravitational force times height. So what we can have there is mgh, that is the force that we have, which is 5,000 Newton. Okay, so which is the product of mg, that is 5,000. So the mass of the mass, we can take it that it's 500, so times that will give us 5,000. Okay, then 5,000 Newton times height, which is 24. Okay, then what we can get now from there is the same amount we got, which is 120,000 joules. So 120,000 joules is the amount of energy, potential energy, is the amount of potential energy. Okay, let's go to question 3C, which is calculate the power developed by the blocks. Calculate the power developed by the block. So how do we find power? I'm sure in section A I demonstrated. So to find power, we use power is equal to work done, which I will abbreviate to be WD over time. Okay, so what is the work done? Okay, what is the work done? So let's go on question 3A. We found work done to be 120 joules. So what we're going to do is we're going to say 120,000 joules over time. So how long did it take, okay, for that work to be done? That was, it takes 4 seconds to reach the top of the building. So 4 seconds. So on time, we're going to say 4 seconds. Okay, so now what we can do is we can go ahead and simplify. So what we can do is we ignore the zeros and then we focus on 12 and 4. So 12 into 4, it will go 3 times. Then there are 4 zeros, so we say that one will be 4,000. Now since it's power, we are calculating power that will be in watts. So the correct answer is 30,000 watts. Okay, unless if you have got questions. If there are no questions, so that is the answer for that question. Okay, if you haven't subscribed to my YouTube channel, I invite you to subscribe to my YouTube channel. If you found this video helpful, remember to like and share with your friends. Let's continue. We come to question 4, which is figure B4.1, shows a graph of solid pure substance changing its state of matter as it is being heated. Okay, so you can take time and study that diagram. Now once you have studied that diagram, we have taken time and studied the diagram. You can pause the video and take time and study the diagram. Okay, once we have studied the diagram, we can go to the actual questions, which are: what is the boiling point of the substance? What is the boiling point of the substance? Okay, so in other words, they're asking us at what temperature is the substance changing its state from liquid to gas. That is what that question is asking us. So let's go to the diagram and see. So at A, it was a solid and the temperature increased. At B, it changed from a solid to liquid, and then it started boiling. At D, it started changing from liquid to gas. So that is 40 degrees Celsius. 40 degrees Celsius. So there we can put the answer to be 40 degrees Celsius. Okay, then question B is at which temperature will the substance exist both at a liquid and a gas? Okay, temperature. So when we go there, we can see that between this point C, between this point so D and E, the substance will exist as a liquid and gas between D and E, and the temperature is 40. So again here we can say that is at 40 degrees Celsius. Okay, so now there we have done the question. So we can go now to question C, which is state one difference between boiling point and evaporation. Okay, between boiling point and evaporation. Okay, so let's answer this question. Okay, so here it should be 40, not 4 degrees Celsius. That is 40 degrees Celsius. Please be careful as you record your answers. Let's hope if you, okay, they have recorded properly. That is 40 degrees Celsius. Please make sure you record the actual weight that you are thinking, the actual number that you are thinking of. So if I take 4 degrees Celsius by mistake, they want to know that it was a mistake. They'll think I'm thinking of 4 degrees Celsius. So I should record my answers properly. Okay, so let me give the answer to question C, which is state the difference between boiling point and evaporation. So I'm going to list about 4 differences. I'm just going to write one. I'll talk about 3. Okay, so what happens, what is about boiling point? Let me start with the one that is the one I'm going to record. So boiling point, bubbles are formed, where evaporation, bubbles are not formed. So under boiling point there are some bubbles. So bubbles are formed during boiling, well, I can also, well, let me, well, bubbles are not formed during bubbles are not formed during evaporation. So if you want, you can also say, I'll give you extra one. I want you to mention the other 2, which you can come up with. Okay, the other one is boiling point. Boiling takes place at a definite temperature, while evaporation takes place at any temperature. Okay, so this means that when evaporation taking place, it can take at any temperature. For instance, let's talk about water. The boiling point for water is 100 degrees Celsius. That's where the boiling point takes place. However, evaporation takes place at any point. Even before the water reaches 100 degrees Celsius, evaporation will be taking place. So evaporation takes place at any point, as long as there is different in temperature between 2 surroundings. Evaporation will start taking place. Okay, so that is the other point. So I want you to mention 2 in the comment section. Which one can you write in the exam if this question came? Okay, now let's go to D. What happens to the heat supplied at points where there is no increase in temperature? Okay, so let's go back to the diagram. So the points they are talking about is B, C, and D, E. These 2 points. Okay, what is happening to the temperature here? Because there is no increase in temperature. What is happening to the heat that is introduced to the substance during this period? Okay, so what happens to the heat there is that what is happening there is the heat is used to convert the substance into another state of matter. Okay, so in a scientific way, what we are trying to say is the heat is used to break down the bonds or weaken the bonds between the molecules. Okay, so we can say it is used to change the state it is used, let me say it is used to change the state, let me say the state of the substance into another state. Okay, for instance, when the substance was a solid at BC, the substance, the temperature didn't rise because the heat was used to change the substance from solid into liquid. When at DE, when the substance was changing from liquid to gas, the heat was used to change the substance into a gas, from liquid into a gas. Okay, so the heat, there is no change in temperature because the heat is used to change the state of the substance into another state. So it's being used by converting the state into another state, okay, of matter. So that is the explanation. Please, if you have got a better explanation, you can write it in the comment section. I'll still gladly accept it and comment as well, because I know there is a better way you can. Come to question 5, which is as follows. Figure B5.1 shows a wave with a frequency of 40 Hz. Okay, so you can take time and study the diagram. Okay, now once we've studied the diagram, let's go to the actual questions, which is 5A. Define amplitude. What is amplitude? So you can say amplitude is amplitude is the height, is the height of a wave from its middle point, which from its middle point from its middle point to the top or bottom. Okay, so that's how I can define amplitude. I know there is another way you can define it. If you have another way, the better way and the shorter way that can be easily be remembered, you can also write it in the comment section. So I say amplitude is the height of a wave from its middle point to the top or bottom. Now, many are the times that you find it's written rest. So middle point is also referred to as rest, as well as the top point is also referred as crest, and bottom is also referred as trough. Okay, I don't know how you pronounce it, if it's trough or trough. Okay, but those are the points that you should also bear in mind. Okay, middle point, rest, top point, rest, crest, and bottom, trough. Okay, now once I've done that, we can come to the actual question, to the question B, which is question B is calculate the speed of the wave. Okay, we need to calculate the speed of the wave. So to calculate the speed of the wave, like I did in section A, we use this formula, which is wave speed is equal to which is equal to frequency times wavelength. Okay, times wavelength. Okay, let me write my wavelength symbol properly. Let me write it properly. So it's like this, then like this. Okay, so what we can do is just put the what is the frequency. So we are told the frequency is equal to 40. We are told the frequency is 40 Hz. So we are going to write 40 Hz times wavelength. So what is wavelength? Okay, what is wavelength? So we can go there and check. Wavelength is 1.5. You can see on the diagram there. That is wavelength. That is 1.5 there. Okay, so we can say now the wavelength is 1.5. Sorry, I don't know what is happening. Okay, we say times 1.5. meters. Okay, so now we evaluate that. So when we evaluate that, we're going to get the speed of you can say that is times that will give us 60 that is 60 meters per second. That is 60 meters per second, and that is the speed of the wave. So we can write our 60 meters per second here. Okay, unless if you have got questions, but that's how you find the speed of the wave. That okay. So okay, we come to question C, which is find the period of the wave. Find the period of the wave. So to find the period of the wave, we're going to use the formula, which is period is equal to T1 over frequency. So we're going to say equal to 1 over what is the frequency. So we are given the frequency there. We are given the frequency there, which is 40 Hz. It's here. The frequency is here, 40 Hz. So once we have written that, we have identified that. So we say 40 Hz. Okay. Then what we do is we divide 1 divided by 40. 1 divided by 40. So we say 1 divided by 40. So for 1, can 40 go into 1? No. So we write 0. Then we put 0 to 1, it becomes 10. Then we put a decimal point here. Can 40 go into 10? No. So we put 0 here and we write 0 here. Then we say, can 40 go into 100? Yes. How many times? 2 times. So we write 2 there. Then we say, what will be the remainder? It will be 20. So 40 will go into 100 2 times, leaving us with 10 to 20 as a remainder. Then can 40 go into 20? No. So what we do, we put a 0 here. Then we say, can 40 go into 200? Yes. How many times? 5 times. Okay. Is there any remainder? No, there is no remainder. So that means our calculation has ended, and we just put the unit there, which is second. So the period for the wave is 0.025 seconds. Now remember that is seconds, those are not fives, because I can see that my S is almost similar to the 5, so please don't be confused. That is seconds there. Okay, so basically that's how you go about this question. If you have got questions, you can ask in the comment section, but otherwise that's how you go about it. To question 6. Question 6 is as follows. Figure B6.1 shows the rays of light in a semicircular glass block. Okay, so we can take time and study the diagram. Now once we have studied the diagram, we can go to question A, which is 6A. Define critical angle. Define critical angle. What is critical angle? Okay, so we can define critical angle as critical angle is the angle of incidence that gives an angle of reflection of 90 degrees when a ray of light is moving from an optically denser medium to an optically less dense medium. That is a critical angle. Okay, so this is the way I can define it. You can also define it your own way in the comment section. Okay, let me see how you define critical angle. Okay, or what words do you use as you describe critical angle? Okay, let's come to question B, which is explain why the ray entering the glass at A is not diffracted. Why the ray entering at A is not diffracted. Okay, explain why the ray entering the glass at A is not diffracted. Okay, so why do you think that light is not being diffracted when you look at that diagram? So the explanation you can have for this one is, so because the ray of light entered the glass block at 90 degrees. Okay, so that is the answer to the question, which is explain why the ray entering the glass at A is not diffracted. So it is because the ray of light entered the glass at 90 degrees. Okay, now let's go to question C, which is explain why the ray AB is refracted at B and not diffracted. Explain why the ray AB is reflected at B and not refracted. Okay, so the answer to this one is because the angle of the incidence is greater than the critical angle, hence total internal reflection occurs. Because the angle of the incidence is greater than the critical angle, hence the total internal reflection occurs. So that is the answer to the question, which is explain why the ray AB is refracted at B and not diffracted. So the answer is because the angle of the incidence is greater than the critical angle, hence total internal reflection occurs. Okay, so now let's go to question D, which is as follows. On the diagram, complete lay CB to show the approximate path it takes as it leaves the grass block. On the diagram, complete lay CB to show the approximate path it takes as it leaves the grass block. Okay, so we can go back to the diagram, and then we want to complete the lay CB. So which one is lay CB? That this is the lay. So how can we complete it? So we go there. Okay, so what will happen is when it reaches that side, it will diffract to this angle, to refract to this side. So that is the approximate lay that will be formed as it leaves the block, the grass block. Okay, so basically that is the answer to this question. Okay, so basically if you have got questions, you can ask in the comment section, but this is how you answer these questions. We come to question 7, which is figure B7.1, shows a soft iron bar magnet. Figure B7.1 shows a soft iron bar magnet. So we can take time and study the iron bar. Now, once we have studied that, we can come to the actual questions, which is question A1, which is draw the magnetic field lines resulting from the poles of a magnet shown in figure B7.1. Okay, so what we can do is to draw the magnetic fields, that is, we can draw it like this. I may not be accurate with the way I'm drawing, but approximately this is how we draw it, and again we draw something like this. Okay, so this is the magnetic field of the bar. Okay, now once I've drawn it like that, please bear with me, it should be a halo pointing like that. Okay, then once we've drawn like that, we have answered question A1. Now we come to question A2. Give two properties of the magnetic field lines. What are the properties of these magnetic? Okay, so we come to question B is as follows. Question A2 is give two properties of the magnetic field. Give two properties of the magnetic field. So the first property I can share with you of the magnetic field is the magnetic field is stronger in regions where the field lines are closer together. The magnetic field is stronger in regions where the field lines are closer together. Okay, so the more the magnetic lines are closer, the stronger they are. Point number 2 is they run from the North Pole to the South Pole. So if we come to the diagram here and take a look at it, you'll find that the lines are running from North to the South Pole. North to the South Pole. As you can see, the arrows are pointing. Then you have been asked to give two properties. So I can give you the third one in case you want to use it. Maybe you forget one, you may remember the other one. So the other one is they do not cross over each other. So these lines, they do not cross each other. So these are the properties of the magnetic field lines. They don't cross over each other. Okay, now we come to question B, which is state two effects the poles of a magnet have on the poles of the other magnet. If you get two magnets, okay, and then you put them together, what will happen? Okay, so the effects they have is there is a force of attraction or repulsion. So when you bring two magnets, it's either they will attract each other or they will repulse each other. So the answer there is there. So that point I've raised can gain you 2 marks. It's either there is a force of attraction or the force of repulsion when you bring two magnets together. Okay, so those are the answers. If you have got questions, you can ask in the comment section, but basically those are the answers that we are expected to write in the exam. To question 8, which is as follows. Figure B8.1 shows a cathode ray oscilloscope. Okay, so we can take time and study the diagram. So once I've studied the diagram, the first thing we need to do is let's name the parts that are labeled by letters. So to name these parts that are labeled by letters, what we're going to do is we're going to start with A. What is A? A, that is grind. B, that is anode. C, that is vertical diffraction plates, and D, that is horizontal diffraction plates. Okay, now I've named those parts. We can go to the actual questions. The actual question, which is question 8A, is name the parts labeled A and B. So the part labeled A is, we have named it, that is grind already. So we have named it as that is grind. Okay, then B, we have named that as anode. So that is anode. Okay, so that is anode. Okay, so those are the parts. Now we come to question B, which is state the function of the part labeled C. What is the function of vertical diffraction plate? What is the function of vertical diffraction plate? So the function of vertical diffraction plate is to diffract the electron's beam vertically. To diffract the electron beam vertically. Okay, now we come to question C. State how the electrons are produced in the cathode ray oscilloscope. Okay, so state how the electrons are produced in the cathode ray oscilloscope. Okay, the answer there is electrons are produced by heating the cathode. Electrons are produced by heating the cathode. Okay, now we go to question D, which is question D is explain why the tube of the cathode ray oscilloscope is evacuated. Explain why the tube of the ray oscilloscope is evacuated. The answer is the tube is evacuated so that the electrons are not hindered while moving from cathode to anode by collision with the air molecules. Okay, so basically these were the answers that the examiners expected you to write in the answer spaces. So if you have got questions, please you can ask in the comment section. Otherwise, this is how you go about this question. We come to question 9, which is figure B9.1 shows the graph of the count rate in counts per minute against time in minutes. Okay, so what you can do is you can take time and start the diagram. Okay, now once we have started the graph, we can go to the actual questions, which is question 1, which is define half-life. What is half-life? Okay, so we can define half-life as follows. It's the time taken for the activity of radioactivity sample to decrease to half of the initial value, or the time taken for half of the number of radioactivity nuclei present to decay. Okay, so you can pick any part of the definition. So there are two varieties of the same definition, so you can pick any of the two. We come to question B. Question B is use the graph to determine the half-life of the radioactivity sample. So we're going to use the graph to determine the half-life of the radioactivity sample. Okay, so what I want us to do is let's concentrate on the diagram. Then what we're going to do is we are told that shows the graph of count rate in count per minutes against time in minutes. So what we're given here, we have given 12. Okay, so half of 12 is 6. So how long did it take for it to reach 6? So when it comes to time, if we are to do this, if we come to time, it took, that is 2 minutes. Okay, so it took 2 minutes to reach half of the what was given, the initial reading. Okay, so it took 2 minutes to reach half of the initial reading, which is 12. So half of 12, it took 2 minutes. Okay, so half-life of this is 2 minutes. Okay, now when you look at from 6 to reach 3, it's here. So for it to reach 3, you'll see that it is going to take about 2 minutes again. 2 plus 2 will give us 4. Again, for it to reach this point 6 here, so which means it's going to take again half of that to reach this. Okay, so that is per 2 minutes, half of that life was it decreased by half of that life. Okay, so that means the answer is 2. So what we can do is now we can go to the questions and answer the questions. Okay, so we go to question B, which is use the graph to determine the half-life of the radioactivity sample. So the correct answer is 2 minutes. The correct answer is the half-life is 2 minutes. Okay, now we come to C, which is give 2 effects of radioactivity substances on the environment. So they're asking for 2, but they are main effects of radioactivity on the substance. So we can start with 1. It causes genetic mutation. It causes genetic mutation. The other one is it also causes cancer. Okay, so cancer, leukemia, examples of cancers, those kind of cancers, it also caused by radiation. So that is why in hospitals they minimize the chances of having an X-ray. Okay, so that they reduce on the number of you coming in contact with the radioactivity. Okay, then the third one, they want 2, but I'll give you 3. The other one is chemical changes in living organism. So that's why we have cancer, because there is some changes that takes place in living cells. Okay, and that's why we have even genetic mutation. So if you can pick 2 of those reasons I've given you, you are going to get 2 marks for those. If you've got questions, you can ask in the comment section. If you haven't subscribed to my YouTube channel. Otherwise, let's go to the next question. Here we come to section C, which has got 20 marks. So the instructions for this section are as follows. Answer any 2 questions from this section. Write your answers in the spaces provided in this section, in this question paper from pages 18 to 22. Write the numbers from the questions you have chosen at the beginning of each answer. Okay, so those are the instructions. Now for me, I'm going to answer all the 3 questions because we are revising, so I'm going to answer all the 3 questions so that I can demonstrate on how you can answer in case people have different choices. That means all the 3 questions will may be answered, okay, in an exam, even though people only answer 2, but different people will choose different questions. So that's why I'm going to go through all the questions so that those who have got the option to choose 1 and 2, they can also learn, and those who have the option to choose or those who intend to choose 1 and 3, you can also learn on how to answer question 3. So I'm going to answer all the questions so that I can cut for everyone. So let's start with question 1, which is a car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds. It then moves with this velocity for 3 seconds and then come to rest in 2 seconds. 1, which is 1A, plot a graph of velocity against time for the motion of the car on the grid provided on page 18. Okay, so for me, what I've done is I've just picked a graph from that page and I've brought it here. Okay, so we can see the graph that we're going to use now. To save time, I have already written the readings on the graph. That's what you need to do. So you can see down here I've got time. So let me write. I've got time. Okay, down here, that's where I've written time, which you can see 0 seconds, 1 second, 2 seconds, up to 10 seconds. Okay, then here I have got speed, which is also a velocity. So this side, that is velocity. Okay, so I've got velocity this side. Okay, so now when you come to the actual question, we are asked to plot the graph. Okay, question A, 1A is asking us to plot a graph of velocity against time for the motion of the car on the grid provided. Okay, so what we're going to do is going to plot the graph. Okay, so let's plot the graph. So to plot the graph, we're going back to the statement. A car slows down from a velocity of 40 minutes per second to 20 minutes per second in 5 seconds. So what we're going to do is we are going to come at this point. Okay, so from this point we are going to move from this point up to 20 seconds, and that the time we should take is 5 seconds. So 5 seconds is here. So that means we're going to draw a line which demonstrates constant like constant change of speed, that is constant deceleration. Okay, like that. Okay, now once we have drawn like that, that means now we have drawn the movement of the car from 40 meters per second to 20 meters per second in 5 seconds. Now you can see here is 5 seconds. Okay, so from 40 to 20, time taken is 5 seconds. Okay, now once we've drawn that, we can go now to the next statement. Okay, the next statement is from there. Now we can say it then moves with this velocity for 3 seconds. So that means it moves at 20 meters per second for 3 seconds. So when we add 3 seconds to 5 seconds, we're going to get 8 seconds. So that means from where we have, so we're going to start from 8 like that, then we draw. So from 5 to 8, the velocity was constant. So that means we're going to have something like this. Okay, now after we've done that, then we can go to the other part, which is same, and then comes to rest in 2 seconds. So it comes to stop in 2 seconds. Okay, so that means after moving at 20 meters per second for 3 seconds, then it came to rest. So that means from 20 meters per second to 0 meters per second. That means it stopped. So what we can do is now, again, what we'll do is we'll come here and then draw a line from here up to 10. So we are told to say it came to rest at after moving for 2 seconds. Okay, and let me just log. Okay, so it came to rest after 2 seconds. So first 5 seconds it moves from 40 meters per second to 20 meters per second. Then it came to it moved for 3 seconds on the constant speed of 20 meters per second. Then later on it reduced, or it came to rest after 2 seconds. Okay, so 5 seconds it moved, it reduced the speed from 40 meters per second to 20 meters per second. Then for 3 seconds it moves at 20 meters per second. Then after 3 seconds it took 2 seconds to come to rest from 20 meters per second to 0 meters per second. So it took 2 seconds to come to that to rest or to stop. So that means that's how you draw the graph, just like I've drawn there. Okay, so now we have answered question A correctly. That's how you answer it. So we can go to question B, which is calculate the retardation in the first 5 minutes. Okay, so what I'm going to do is I'm going to use the same space because my space is not too big, so I'm going to use the same space. So what I want you to bear in mind is, as I write, you can have a space where I also be recording my writings, so that when I lap, you can remain with those on your books, or you can watch the video if you want to check what I did when I was calculating the retardation. We come to question B1, which is calculate the retardation in the first 5 seconds. Calculate the retardation in the first 5 seconds. Okay, so to calculate the retardation in the first 5 seconds, what we're going to do is we're going to come up with the formula, which is so let's see, let me write first B, question B1, which is the selection is equal to initial velocity, final velocity minus initial velocity over time. Okay, so when you look at what is the initial final velocity, so the car was moving at 40 meters per second, and it came to 20 meters per second. So the initial the final velocity is 20 meters per second minus initial velocity, that is 40 meters per second. Okay, so what is the time it took? It was in 5 seconds. So it was in 5 seconds. So we write 5 seconds down here. Then we say equal to. So we find the difference of 20 and 40. So since 40 is bigger than 20, well, that means we're going to maintain the negative sign for which is with the bigger number. Then we find the difference of 40 and 20, which is 20 meters per second. So subtracting 40 from 20 will give us negative 20 meters per second, and divide by 5 seconds. Okay, divide by 5 seconds. Okay, so when we divide negative 20 by 5 seconds, we're going to get the answer, which is negative 4 meters per second squared. Okay, this is the acceleration. So now we are told to find retardation. So we can say what is retardation? So we can say retardation is 4 meters per second squared. That is retardation, 4 meters per second squared. Okay, if you have got questions, you can ask in the comment section, but basically that is the answer that examiners wanted. So after finding the deceleration, you write it like this: retardation is equal to 4 meters per second squared. Okay, if you have got questions, please don't hesitate to ask in the comment section. Okay, if you haven't subscribed to my YouTube channel, I encourage you to subscribe to my YouTube channel, and if you find this video helpful, remember to like and share with your friends. Now let's go to question B2. Question B2 is as follows: calculate total distance covered by the car. Calculate total distance covered by the car. So what I usually do is I also encourage my students to do the same. Okay, so for those who have got issues with the formula for trapezium, I want you also to try this one. So what you need to do is first you divide these into triangles and rectangles, so that you don't come up with the trapezium. So you come up with these shapes. Okay, so I have got 3 shapes there. The first shape is one here, that is a triangle. This is the triangle, and this is rectangle, and the third shape is triangle. So I've got 3 shapes there, and those are the ones I'm going to find the area for, and then add their areas, and that will be the total distance covered. So let's go ahead and solve that one. So I'm going to say 2 b2, sorry, this is question 2b, b2, not 2b, b2. Okay, so we're going to say total distance, so we can say total distance, which I'm going to say TD. Okay, that is total distance. So the formula we're going to use is 1/2 times L times P. Okay, so you can even say LH, it's okay, or BH, I don't know, whichever you prefer. So as long as you get the dimensions that I'm going to get, you're going to get the answer correct. Then plus L times B for the rectangle shape, and then plus open bracket 1/2 times L times B, cross bracket, like that. Okay, so what happens here now, we are going to say equal to, so we are going to open bracket and say 1/2 times, so first let me start with the triangle one. So this one is equal to 5 seconds, so that means I'm going to take 5 as the length. So I'm going to say 5, it doesn't matter which one you get as the length, so we're going to get that one 5, then times this one is 40, from 40 to 20, so the difference is 20, so I'm going to also to put 20 there. Okay, then cross bracket, then plus L times B, so I'm coming to rectangle which is B, so it is 0 to 20, that is 20 there, then there is 8, so I'm going to have dimensions as 20 times 8, cross bracket, then plus 1/2, this one should be in brackets, then times, again here we have got 2 down there. Okay, so we say 2 times, then height we are given 20, so we put 20 there, like that, then we close bracket, like that. Okay, so now once we've done that, we can go ahead and differentiate what is in the box. Okay, what is in brackets, not box but in brackets. So the 2 down will be cancelled out, so 2 into 2, that's 1, 2 into 20 will give me 10. Okay, so there we have got 1 times 5 times 10, 1 times 5, we are remaining with 1 times 5 times 10 on 20. On 20 we have 10 because we divided by 20 by 2, which give us 10. So 1 times 5, it's equal to 5. 5 times 10 will give us 50. So that one we can say that is 50 meters, plus 20 times 8 will give us 160 meters, then plus 2 into 2, they'll cancel each other out, so that means we have 1 there. So 1 times 1 times 1 times 1 is 1. 1 times 20 is 20, so I've got 20 meters there. Okay, then what we do is we just find the sum of those. So 5 times 160 will give us 210. 50 times 160, 50 times, what am I saying, 50 plus 160 will give us 210, plus 20 will give me 230. So I'm going to write 230 meters. Now that is the total distance covered by the vehicle. 230 is the total distance covered by the vehicle. So basically that's how you can go about it. Okay, if you have got another way of finding this one, tell me in the comment section how you find it. I'll be glad to share with you. Okay, to learn from you as well, I'll be glad to learn from you. So basically this is how you find the total distance. Okay, if there are no questions, you can just subscribe to our YouTube channel if you haven't subscribed to our YouTube channel, and if there are questions, please ask in the comment section. I'll be glad to respond to your questions. Okay, now we come to question B3. Question B3 is as follows: the average speed of the car. Calculate the average speed of the car. So question B3 is as follows: calculate the average speed of the car. Okay, so what are we going to do? So what we're going to do is we're going to find the average speed of the car. We are going to use this formula. So we're going to say, let me say B3. Okay, so we're going to use this formula, which is speed is equal to distance, okay, over time taken. Okay, so now we are just from finding distance that was covered in question B2. Okay, so we are going to say what is the distance we got? We got 230, okay, meters over what is the time that was taken? That was 10 seconds. So we're going to say over 10 seconds. Okay, so the vehicle covered 230 meters in 10 seconds. Okay, so now the question is, what is the speed? So that's what we want to find. We want to find speed. So what we do is we just cancel this 0 and this 0. Once we cancel the 0 on top and the 0 down, what we are going to have is 23 on top. So we say 1 into 23 will give us 23 meters per second, and that is the speed. Okay, so basically that's how you find the speed, the average speed. So that means the average speed is the speed of the total distance covered. Okay, the average speed, we are trying to find the speed of the total distance covered. We know that there was change of speed during the journey, but we want just to find the average speed. Okay, so that was 23 meters per second. 23 meters per second. Okay, so if you have got questions, you can ask in the comment section. But basically, this is how you find the average speed of the car. Okay, so please make sure you subscribe to my YouTube channel and also share this video if you found it helpful. Remember to invite your friends to subscribe to our YouTube channel so that we can impact our lives or your lives positively together. So make sure invite your friends, your family members to be part of our YouTube channel, so that we continue doing the great things that we are doing. Okay, we come to question 2, which is question 2 as question 2 is as follows. Table C 2.1 shows values of voltage V and current A recorded by a learner observing different current passing through a torch as voltage was being increased. Okay, so these are the results the child recorded. So you can see on voltage we have got 2 volts, 3 volts, 4 volts, 6 volts, 8 volts. And then on current we have got 1, we have got 1.5, 2, 3, and 4. Okay, so now let's go to the question. The actual question is answer part A, D, and E on page 20. Okay, so the question is when you're giving these answers, you use page 20. So for me, I'm going to use the same space to answer all the questions. Okay, so let's start with the question 2A, which is state Ohm's law. What does Ohm's law state? Okay, Ohm's law states that the current passing through a conductor is directly proportional to the potential difference across its ends, provided the temperature is kept constant. Okay, Ohm's law states that the current passing through a conductor is directly proportional to the potential difference across its ends, provided the temperature is kept constant. Okay, that is what Ohm's law states. Okay, now we have answered question A. We go to question B, which is plot a graph of voltage against current using the values given in table C 2.1 on the grid provided on page 19. Okay, so forget about page 19 and other things. I've brought the graph here on the screen as you can see it. So during the exams, you need to go to page 19 and answer question on that page. Okay, so now we go to the graph. Now remember, I've put the numbers. This was just to help us not to waste time. So that's what you need to do. You need to also write the numbers. Okay, what you can do is, these numbers I've written 1 up to 8. These are for voltage. Okay, these are for voltage. Okay, then the numbers which I've written down 0 to 4, these are for current. Okay, these are for current. So sorry if the word is not seen clearly, but these are for currents, which is denoted by I. Okay, so sorry, the graph is too big that the weights cannot be seen, the current weight cannot be seen down. Okay, so now what I'm going to do is I'm going to show you how we can plot a graph. Okay, so how do we plot a graph? So we can, well, let's start with a point 1 where the voltage is 2 and the ohms is, sorry, the ampere is 1.0, the current is, voltage is 2.0 volts and the current is 1.0. so let's start by plotting that first. Okay, so we are saying the voltage is 2, then the voltage is 2, the ampere is 1, so the current is reading 1 ampere, then the voltage is 2. When the voltage is increased to 3, then the reading on the current on the ammeter is 1.5. so in that way, that's how we're going to move. Then when the voltage is 6, the reading on the ammeter is 3 amps. Then when the voltage is 8, the reading on ammeter is 4. So like that, that is the graph we're going to come up with. Okay, so we have drawn the graph like that. So basically that's how you draw the graph there. Okay, so we have answered question B, which is plot a graph of voltage against current using the values given in the table C2.1 on the grid provided on page 19. Okay, we have answered that one, so I have drawn the graph. Okay, so that's how you draw the graph. So now we come to question C, which is use the graph to determine the resistance of the filament of the torch. Okay, so how we can use the graph, okay, to determine the resistance of the torch, of the filament of the torch. Okay, so we all know that resistance is equal to, so we can say resistance is equal to voltage over current. Okay, so we can pick any point, that we can use. So if you want, we can pick 3. We can pick this point here. Okay, let me just show you. We can pick 6 and also pick 3. Okay, so we pick voltage 6 and we pick current 3. Okay, 3 amps. So what we do is we are going to write the same. So where there is voltage, we're going to put 6. Where there is current down, we're going to put 3. Then we find the resistance. So 3 into, remember this is 6 volts and this is 3 amps. So 3 into 6 will give us 2. So it will be 2 ohms. Okay, so that is the ohms. So we can determine the resistance of the filament is 2 ohms. Okay, maybe in case you're saying, but what if we use 3 volts? Okay, so when you use 3 volts, okay, so where the line is, so it's going to come here. So here, as you can see, it's in the middle of 2 and 1, so that will be 1.5. So if we are to use that one, okay, if we are to use that one, 3, where the voltage is 3, so I'm going to use the same formula. Okay, I'm going to use the same formula. So if the voltage is 3, so we say voltage is 3, then the current, the reading on the current is the ampere is 1.5. So this is volts and this is 1.5. So when we divide 3 by 1.5, we're going to get 2 ohms again. Okay, so that is the answer, 2 ohms, using the graph. Okay, determine. Okay, that is 2. Okay, so if you have got questions, you can ask in the comment section, but basically this is how we go about it. Okay, so we come to this question we're answering was question C. So this was question C. So we come to question D, which is calculate the energy dissipated by the torch if it operates for 45 minutes when the voltage is 5 volt and the current is 0.25 amps. 2D is as follows. Calculate the energy dissipated by the torch if it operates for 45 minutes when the voltage is 5 volts and the current of 0.25 amps. Okay, so what we need to do is we need to find the electrical energy. So to find the electrical energy, we use the formula, which is, so the formula for finding electrical energy is energy is equal to power times time. Okay, this is T times time. Okay, power times time. Okay, so now we come to the next point. Now are we given power? We are not given power. So what we need to do is we need to find power. So to find power, we are going to use the formula, which is power is equal to the formula for power is equal to voltage times current. Okay, so what is the voltage in the statement? So we're given 5 volts. So we have 5 volts given. Then current, we are given 0.25 amps. So we say times 0.25 amps. Okay, then what we do is we multiply. Now here is a secret of how we multiply decimal numbers. First, we are going to move this point to the right so that 25 becomes a whole number. So it means like this point will go 2 steps to the right so that it becomes 25. So 25 times 5 is going to give us 125. Okay, 125. Then what we do now here, the point will come back again. Now it will move from right going to the left. So it is at the end here. So the point will move like this and comes there. Okay, so that means we are going to have a number which is 1 point, because the point has come there. So the answer will be 1.25. Now it's power. We have found the power, that is, we have found power which is in watts. So this is the power, okay, when we multiply the voltage by current. Now once we have found the power like that, then the next thing we're going to do is going to now write power. On the place of power, we're going to write the value we got, which is 1.25 watts times. Now we come to time. Now remember, when you are calculating electrical energy, time is in seconds. Now we are given time which is in minutes, so we need to convert 45 minutes into seconds. So how do we do that? We are going to write 45 there on top, then multiplied by 60. Why are we multiplying by 60? Because there are 60 seconds in 1 minute. There are 60 seconds in 1 minute. That's why we're multiplying 45 by 60. Then what we're going to do is we are not going to multiply 45 by 0. We are going to waste time. So what we do is we just write 0 here. Then we start multiplying 45 by 6 or 60 by 45. So you say 6 times 5 will give me 30. So I'm going to write 0 here, carry 3. 6 times 4 will give me 24 plus 3, 27. So I'm going to put 7. I'm going to write 27 like this. The entire 27, because there's no other number that I'm going to multiply by 6 on top. So the answer is 12,700 seconds. So we multiply this number by 2,700 seconds. Okay, remember we're trying to find electrical energy. So now what we have come to is let me use the top part there. Let me use the top part there to multiply 1 point. Let me just say I'm going to multiply 125 times 27. Okay, so if you don't understand this, I can tell you why I'm multiplying by 125 times 27. I just want to not to do with the decimal number. So meaning I've used the 2 zeros to move the point to the left side, to the right side, so that it becomes a whole number. Okay, it should give me the same correct answer as if you have multiplied 1.25 by 2700. So we say 7 times 5 will give me 35. So I'm going to write 5 carry 3. 7 times 2 will give me 14 plus 3, 17. So I'm going to write 7 there. 7 times 1 will give me 7 plus 1, it will be 8, like that. Then I put a 0 here. Then I say 2 times 5 will give me 10, so I'm going to write a 0 here. Then 2 times 2 will give me 4, so I'm going to write 4 here. 2 times, it will be 4 plus 1 to be 5 here. Then 2 times 1 will give me 2. Okay, then what I'm going to do is I'm going just to add the numbers. So I'm going to have 5 here, 7 here, then I'm going to have 8 plus 5 will give me 13. So plus, I'll carry 1 here. 1 plus 2 will give me 3. So the answer is 3,300 joules. Okay, so I'm going to write my answer there, which is 3,375 joules. Okay, so this is the energy. Okay, this is the electrical energy that the torch dissipated. Okay, if you have got questions, you can ask in the comment section. I've tried to be as detailed as possible. So basically, this is how to answer this question. Okay, we come to question 2E, which is as follows. What does it mean in terms of electrical energy when the bulb is rated 120 watts? What does it mean in terms of electrical energy when the bulb is rated 120 watts? Okay, so what it means is this. It means it converts 120 joules of electrical energy every second. So when the bulb is labeled 120 watts, it means it converts 120 joules of electrical energy every second, or every second, not seconds, but every second. Okay, so basically these were the answers that examiners were expecting you to write during the exam. So if you have got questions, please don't hesitate to ask in the comment section. If you haven't subscribed to my YouTube channel, I encourage you to subscribe to my YouTube channel. And if you found this video helpful, remember to like and share with your friends. Thank you so much for watching. Let's go to the last question. We come to question 3 of section C, and the question is as follows. A wave on a string moves through a distance of 20 meters in 0.1 second. A wave on a string moves through a distance of 20 meters in 0.1 second. A. Define longitudinal wave. Define longitudinal wave. So what is longitudinal wave? So we can define longitudinal wave as follows. Longitudinal wave is a wave in which particles move parallel to the direction of the wave. So longitudinal wave is a wave in which particles move parallel to the direction of the wave. Okay, so that's how you answer question 1 there. Okay, now we go to question B. So we have answered question A. Now we go to question B. So question B is as follows. Calculate the velocity of the wave. So we want to calculate the velocity of the wave. So calculate the velocity of the wave. So how do we calculate the velocity of the wave? So we are going to call this is question B. So I'm going to write B. Sorry, I'm going to write B, which is as follows. So that is question B. So to calculate the velocity of the wave, we're going to use velocity is equal to distance over time. Okay, so distance over time. So what is distance? We are told that is 20 meters. Okay, let me just abbreviate it. 20 meters, which is going to be m over time, that is 0.1 seconds. Okay, so want to find velocity. So what we're going to do is we're going to divide that. So what we can do is we make this 0.1 a whole number. That means it needs this point to move one step to the right. So that means we're going to multiply both numbers on top and down by 10, which is going to give us 200 meters over 1 second. Okay, so we say should be 200 meters over 1 second. So 1 into 200 to go 200 times, which is 200 meters per second. So that is the velocity, which is 200 meters per second. Okay, so that's how we can do it. So even dividing 20 by 0.1 will give you the same answer, but I just made 1. I just multiplied by 10 to make it 0.1 to be a whole number, which can be easier for me to divide, as you have seen. 1 second into 200 meters, it gave me 200 meters per second. Or 1 into 200, it gave me 200. So it was easier for me to divide 200 by 1. Okay. Then it is easy to divide 20 by 0.1. It might be confusing if you are not careful. Okay, so now we go to question C, which is as follows. So we have answered question B. Now we go to question C, which is figure C 3.1 shows a vibrating string fixed at the ends. Figure C3.1 shows a vibrating string fixed at the ends. Okay, so you can take time and study the diagram. Now the actual question is calculate the period of the wave if the frequency of the vibrating string is 25 Hz and the velocity is 300 meters per second. Okay, so we want to calculate the period. So how do we calculate the period? So I'm going to say C. Okay, so period is equal to 1 over frequency. Okay, so we can say equal to, so we say 1 over, what is the frequency? We have 25, so we're going to write 25 Hz. Okay, which is equal to, so we say how many times can 25 go into 1? How many times can 25 go into 1? It will go 0 time, or 25 can't go into 1. Okay, so what we're going to do, we're going to add 0 to 1 and we put a decimal point here. Then we see how many times can 25 go into 10? It will go 0 time. Then we're going to add 1, we're going to add 0 to 10, then it becomes 100. So how many times will 25 go into 100? It will go 4 times. Okay, so it will go 4 times, which will be 0.004 seconds. Okay, so this is the period of the wave. Okay, this is the period of the wave. Okay, we come to question D, which is state 2 characteristics of sound wave. State 2 characteristics of sound wave. What are the characteristics of a sound wave? What makes sound wave different from other waves? What makes sound wave different from other waves? What makes you to identify that this is a sound wave? Okay, so we are answering question D. So the properties of sound wave are: 1, sound wave can be reflected. 1, sound wave can be reflected. So that is point number 1. Point number 2, sound wave can be diffracted. Okay, then since they want 2, I'll give you 3. Since they're main, I'll give you 3 so that you can use any one which you can remember. The other point is sound wave can be diffracted. Okay, so let me write properly there. Okay, diffracted. Okay, so those are the 3 points that I can raise on this one. These are the 3 properties of sound wave. So a sound wave can be diffracted, a sound wave can be diffracted, a sound wave can be diffracted. So those are the 3 points that you can get. So whichever 2 points you can remember there, you can use them to fit if this question came in an exam. Okay, now we go to question E, which is give 2 ways of minimizing sound pollution. Give 2 ways of minimizing sound pollution. Okay, so 1, let me write first E. So this question is question E. So the first thing you can do is 1, soundproofing the looms. Soundproofing the looms. I'll explain. Let me just write soundproofing the looms or loom. So it can be loom or looms. Okay, wherever the sound is made. Okay, that's the first point. So when we say soundproofing the looms, you have seen maybe studios, more especially let me talk about studios for those who also do music as they attend to school. You have seen in studios, you may find that a studio, maybe the holes of the studio are aligned with the tray eggs. Okay, those the trays for the eggs they have. Okay, so the reason they do that is to soundproof the loom so that the sound that is made in the studio does not go out and pollute the surrounding. Okay, so 1 is soundproofing the looms. Okay, the other point is using double glazed windows. Okay, double glazed windows. This is the other point. Okay, so there are many ways of minimizing sound pollution. So I'll give you 3 since there are many. So I'll give you 3. So let me give you the extra one. So the extra one is using heavy curtains. Using heavy curtains. I don't know if this word curtain is clear. Let me just write it. Heavy curtains on windows and doors. Okay, so you use heavy curtains on windows and doors. Those will trap sound. Okay, so basically those are the points that you can use. So 1, by soundproofing the looms. 2, using double glazed windows. 3, using heavy curtains on windows and doors. Okay, those are the things that you can do that can help to minimize the sound pollution. Okay, so we come to question F, which is what does loudness of sound depend on? What does loudness of sound depend on? So loudness of sound, which I'm going to answer my F with this side. So loudness of sound depend on amplitude. Okay, So amplitude determines the loudness of sound. Amplitude determines the loudness of sound. Okay, sound. Okay, so these are the answers that you are supposed to write. So if you've got questions, you can ask in the comment section, but otherwise these are the answers examiners expected you to write.